Hello guys, welcome to my channel. So those who are watching my video first time, so please like, share and do subscribe to my channel, and also please do support. So now in the series of operation research, we are going to discuss about formulation of linear programming problem. So we have a question says that a company manufactures two types of products, P1 and P2. Each product uses lathe and milling machines, which means a company produces two types of products, P1 and P2. Each product, those products P1 and P2 uses lathe and milling machines for producing the products. The processing time per unit of P1 on the lathe is 5 hours and on the milling machine is 4 hours. Means the processing time of P1 on the lathe is 5 hours and on the milling machine it takes 4 hours. Similarly, the processing time of P2 on the lathe is 10 hours and on the milling machine is 4 hours. So P2 takes the processing time of P2 takes lathe on 10 hours and milling machine is 4 hours. The maximum number of hours available per week on the lathe and milling machine is 60 hours and 40 hours. Means the lathe and milling machine can work per a week only in the 60 hours and 40 hours. Also the profit per unit of selling the products P1 and P2 are ₹6 and ₹8 respectively, which means the profit after selling the products P1 and P2 are ₹6 and ₹8 respectively. So here we have to formulate the linear programming problem to determine the production volume of each of the problems, such as that the total profit is maximized. Here we have to formulate a linear programming problem based on the given question. So for roughly understanding purpose, here manufacture company produces two types of products, P1 and P2, right? Each product uses two types of machines, lathe and milling machine. Right? So the processing time of P1 on the lathe it takes is 5 hours and on the milling machine it takes is 4 hours. So product P1 it takes 5 hours and on the product P1 on the milling machine it takes 4 hours, right? And also similarly P2 on the milling machine takes 10 hours. P2 on the lathe it takes 10 hours and on the milling machine it takes 4 hours. Lathe it takes 10 hours and milling machine it takes 4 hours, right? So here the profit on the products P1 P2 are ₹6 and ₹8 respectively. Profits are ₹6 and ₹8 respectively. This is ₹6. If ₹6 is the profit of P1 and ₹8 is the profit of P2, right? So lathe and milling machine works per week are given that 60 hours and 40 hours. Lathe can work per a week is 60 hours and milling machine can work per a week is 40 hours. So for briefly understanding, I am explaining once again. A manufacturer company produces two types of products, P1 and P2. It uses lathe and milling machines. Lathe can work 5 hours per day 5 hours and milling machine works 4 hours. In similarly, in product P2, lathe can work 10 hours and milling machine takes 4 hours. So the profit of P1 after selling is rupees 6 and profit of P2 is 8 rupees. So this lathe and milling machine can work per a week or 60 hours. Lathe can work in a week and 40 hours milling machine can work in a week. So this is only for your understanding purpose. No need to write in your answer sheets. Next we have to draw a table. So this is how you have to construct the table. Product P1 and P2, how was the machines work, lathe and milling machines, profit per unit rupees. So by considering this, we can easily fill the table. So product P1 takes, so here product P1 takes milling and lathe machines. Lathe machine can work in 5 hours and milling machines can work in 4 hours. 5 and 4, and product P2 takes lathe and milling machine has 10 and 4 hours. 10 and 4 hours. So the profit of P1 is 6 rupees and 8 rupees. 6 rupees and 8 rupees. Okay. So the total number of machines can work in a week or total number of time, 60 and 40 hours. 60 and 40 hours. So this is how we have to construct the table by using this, which can be easily constructed. So next we have decision variable. Let x1 and x2 be the numbers of units of P1 and P2 models. Means we can write P1 and P2 as x1 and x2. We have to consider P1 and P2 as x1 and x2. Understand? Next we have objective function. In objective functions, since we have given the profits of P1 and P2 are given, so we can maximize the profit. So since the profit on both the machines are given, hence we can maximize the profit. Here we have given profit of both the products 6 rupees and 8 rupees, so we can maximize them. We have to max z is equals to profit of P1 is 6 rupees, right? 6 rupees. So here instead of writing P1, we can take x1. Okay, in decision variable we have discussed about this, plus profit of P2 is 8x2. This is the objective function. Okay, next we have to take constraints of products P1 and P2. In constraints we have two machines, right? We have two products, right? Two products, P1 and P2. So we have to construct both P1 and P2 constraints. Understand? Okay. First, the late constraint is given by, so here we have late constraints. Late have product P1 has 5 and product P2 has 10, so we can write as this is for lathe 5x1 plus product P2 has 10x2, right? The total number of hours it can work is less than or equal to 60 hours, because why we are writing less than or equal to means it has given it can work only 60 hours in a week. Okay, that's why we have written 60 hours in a week. That's why we have to take less than or equal to only 60 hours lathe can work in a week. Understand? Next we have the milling machine. The milling machine constraint is given by, here we have for product P1 it takes 4 hours and product P2 it takes 6 hours. Product P1 it takes 4x1 plus and 4x2 less than or equal to 40 hours, means it can work only in 40 hours. Milling machine can work only in 40 hours in a week. That's why we have to write less than or equal to. The milling machine can work only in a week less than or equal to 40 hours. Understand? So first we have these are the constraints of lathe and milling machine. So finally we have objective function has max z equal to 6x1 plus 8x2. Okay, next we have to write the constraints as subject to, we have to write this compulsory, subject to, we have to write the constraints of lathe and milling machine. 5x1 plus 10x2 less than or equal to 60 plus, and next milling machine has 6x1 plus 4x1 plus 4x2 less than or equal to 40 hours, and last x1 plus x2, sorry guys, we don't have to write this, x1 and x2 greater than or equal to 0. So this is how we can formulate a linear programming problem. So after solving this, we have another method which have to be solved, like simplex method, maximum minimum problems. We have to solve all those them. This is just how to formulate a linear programming problem. So guys, for a better understanding, first we have to construct a table considering all the factors. After that we have to take the products P1 P2 has x1 and x2. Then we have to construct objective function. This is necessary to write, compulsory. And next, after constructing objective functions, we have to formulate the constraints of both the products. We have to do only 2 products because there are only 2 products given in the question. After that, constraining the constraints, we have to write like this: max xz is equals to so and so, subject to the constraints have to be written here. This is how we can formulate a linear programming problem. So guys, if you like my video, please do like, share and subscribe to my channel, and also please support to my channel. Thank you. See you in the next video.